each of these sensors just calculate the strain in the direction that they are connected. So just linearly. So in order to calculate shears, because these are just the linear, like the normal strains. So we want shear strain here. So in order to calculate shear strain, we need more than one strain value. So I showed you the theory behind it. You don't need to just like, because you will see these are the strain transformation equations. I just showed you to have an idea. Further in the class, they will show you more circle and this strain transformation equation. So we are not gonna like directly using it. We will just use the product of this calculation. These are just additional information. So if you have two arbitrarily placed strain gauges with, let's say, theta 1 and theta 2, so we have to use this equation, which they have sine and cosine of each of those degrees, and find the strain in each direction, and using those calculate gamma. But we put the strain gauges with 90-degree angle, so some of those cosines cancel out. So the thing that you are using is simply just subtracting epsilon 1 minus epsilon 2. So in each step, so I will apply force and like pause it in 4 steps, like arbitrary numbers. I wrote some numbers here, but I will tell you which load I'm stopping. I might stop at 600 pounds or 550 or 60, 600. Just write down the force that I stop. Don't use these forces that are in the manual. So I will stop loading in 4 different steps, and in each step I will read 2 sensor values, sensor 1 and sensor 2. So the only calculation that you're going to do simply subtracting sensor 1 from sensor 2. Why? You can see these calculations that I showed you here. Why we are doing it? In order to calculate, because we are reading normal strains, we want shear strains. So that's why, in order to find, we need more than one strain value. So we read 2 strain values in each step, and you write down the force and 2 strain values. So calculations are pretty straightforward, and at the end you will have 4 forces and 4 strain values, which you can also find stress. So using the stress strain, so in order to calculate stress, please use the equation tau is VQ over IT. So you have stress value from the equation tau is equal VQ IT, and you have strain values from the experiment. So you can plot tau versus gamma. So having tau versus gamma, from the slope of that line, you can find shear modulus, G. So you have G from this experiment, and I gave you the theoretical value for G. Compare these 2 values with each other and report the error, okay? It's really simple. So I will start to do the test. It's really fast. It's going to be like, let's say, 10 minutes or less. So we again using data acquisition system and the UTM machine to apply the force. You have also photos of, like, I put the data acquisition and beam, how the sensors are connected. So you have this in this instruction in the web course. What else? That's it, I guess. So this time I'm not giving you any initial values. Why? Because when you're subtracting 2 values, so these are going to be cancel out each other. Imagine you have a tape measure, as I showed you the other time. It starts from 10. You're measuring something 16, you're measuring the other thing 26. If you subtract 26 from 16, it's going to be 10. So no matter what was the initial value, because you're subtracting 2 values, it's going to give you the correct answer. Okay? So you don't need to know that, because if you subtract this, both of these initial values will be cancel out each other. So that's why we don't need to know the initial value. Sorry?
The wires hooked up underneath.
Yes.
Support.
No, these wires are for the other test. These are from the back of the other side. I'm just using this sensor because there is another sensor in the back for next, which is like the strain transformation again. Like that. We'll use, because we will calculate the principal strain, which 3 strain gauges we are using in that. But in this one, we are just using this side. So, don't forget, I will read the force, so you write down the force and 2 strain values at each step, okay? Force as a point load, and I will read you 2 strains at each step. So 570 pounds, epsilon 1 is 0.002155, epsilon 2 is 0.002311 for 500. So for 1,250 pounds, epsilon 1 is 0.002098, sensor 2 is 0.02363. For 2,100, epsilon 1 is 0.02035, epsilon 2 is 0.02435. And for 2,550, your epsilon 1 is 0.02005, and epsilon 2 is 0.00247. 0.00247. So these are the values that you guys. So now you have just the only thing that you guys need to know. So because you want to use tau is VQ over IT. So when you have a point load in a simply supported beam, your shear is half of this point load. Just don't forget, V is half of this. So if your P is like say 1,200 that I said, when you are using in VQIT, you have to use half of it. Because in simply supported, your shear is half at each side, yeah? Like you have in the shear. So whatever force I read, when you are calculating, the tau is VQIT, V is half of it, okay? So if you guys want to see the setup, take the photos, you can do it, and don't forget to return your lab